Okay, so today we are going to make an NL4 loudspeaker cable. Now, you might have heard of these before, and you might have heard them called different things. This is what they look like in pieces. Some people will call these speak-on connectors. That's not wrong. They are if you look at the label, they are a speak-on cable connector. But the thing is, speak-on is like the name of a series of connectors. So there's lots of different speak-on connectors. And there are some really, really important differences between them. The main difference is how many contacts are in them. So most of us tend to refer to them by the model number, well, kind of model number description, which tells you how many pins there are. So this one is an NL4 speak-on, meaning it has 4 contacts in it, like 4 wires can go into it. There's such a thing as an NL2 speak-on. There's such a thing as an NL8 speak-on. The thing with, this is primarily used for loudspeaker cables. Why that's a big deal is the cables you've been making so far are pretty low voltage. You know, they're designed to operate with maybe a volt or 2, not a ton of current, you know, so the cables are really thin. You're not, you know, the building's not going to catch on fire because of your XLR cable, okay? But to drive a big loudspeaker with a huge magnet on the back of it requires a lot more energy than that. And so you're going to take that really low voltage signal and you're going to amplify it by a couple orders of magnitude to get it up to quite a high voltage and quite a high amount of current. And it's enough current for it to be a slight concern for, you know, heat and fire, which is what we kind of worry about when we're dealing with what's called high voltage systems. So if you ever go into like installation work where you're installing sound systems professionally and pulling cables into walls, like to pull what's called low voltage cable around in walls and install them, pretty much anybody can do that. If you want to pull high voltage cable through walls and install it and actually expect people to run that kind of electricity through it, you need like a license, and somebody's from the county's going to have to come and inspect that, make sure you did it right. And there's like codes, you know, building codes you have to like follow and all that kind of stuff. Gets a little more serious because that kind of, when you put that much electricity down a cable and stick it through a cable that goes through a wall in a building that's made of combustible materials, if you do that wrong, that wire is going to catch on fire and burn the building down. And when you're talking about loudspeaker cables, you're approaching that universe. You haven't quite got there yet. Like, there's actually a bit of a debate of like, well, is it considered high voltage or low voltage? You know, it's not a huge debate. I think generally we treat it as though it's high voltage, but it's not exactly the same thing as what's powering, you know, your equipment. But it's enough that they're a little squirrely about it. And so the wires are a lot thicker. The cable that you're going to be working with is 12 gauge. So it's a lot thicker wire. There's a lot more copper in there. Because when you run energy, you know, electrical energy down a wire, it can do a couple things with that energy. It can send it down the wire relatively unimpeded, or it can make heat out of it. Those are the two possibilities. And depending on how thick that wire is and how much energy you're trying to put down that wire, that will determine how much heat gets made versus how much energy gets to move. If you get to that point where you're moving less energy and making more heat, that's when things start melting and catching on fire. This is all by way of saying trying to make a loudspeaker cable is a bit more complicated than to do it right and do it safely than what we've been doing so far. And the reason I say there's a bit of a debate among the professional community of like, well, does NL4 count as high voltage or low voltage, is that technically for a high voltage cable, you should not solder that. And here's why. Think about it for a second. Think about the things I just said in the last 5 minutes. Why would soldering a high voltage cable potentially be a bad idea? Yes? You're getting there. Mitch, what do you think?
Solder will melt.
Yeah, what happens to solder when it gets hot? Right? Like, it melts. So there's a risk there, right? Like, if you do this wrong and that cable gets hot enough, that solder could turn back into its liquid form, and then a lot of crazy things could happen, right? Suddenly that solder starts like pooling around all kinds of places, shorting wires together, and that would cause a fire. That would be a big bad deal. And so there's some schools of thought that say you should never solder NL4 connectors. And then there are schools of thought that you should say always solder NL4 connectors because they won't stay together otherwise. There's not a consensus out there about what to do. I will say most of the people I know that pull loudspeaker wire through walls and terminate it onto wall plates with NL4 connectors will solder those connectors. That's pretty common. The alternative is you crimp it to little slide-on terminals and you slide it onto the pack of the connector, which also works but is a lot less reliable. So for the longest time, these NL4 Speakon, or really all of the entire Speakon series of connectors, have not been UL certified. So UL is one of the regulatory bodies that certifies electrical things and makes sure that they're safe. And they have been unwilling to certify Speakon connectors because it has been possible to solder them. And some people solder them and they say, we will not certify it if that's how you're going to do it. We will only, because that's a bad idea for high voltage and we consider this high voltage. And we're like, well, it's not like, it's higher voltage, but it's not like high voltage. And they're like, yeah, we don't care, we're not certifying it. So that becomes a bit of an issue in some contexts and certainly in some countries who are maybe even a little bit more paranoid about these things than we are here in the US. And so Neutrik, who makes these connectors and designed them, has been trying to solve that for a good long while here. And just about a year and a half, 2 years ago, they finally said, we've done it. And they discontinued the entire NL4, the entire Speakon series. They just discontinued them in one fell swoop. And they debuted a new connector design, which is called the NL4, it's the XX series, okay? And the XX series, the main difference is UL certified. So these connectors are UL certified for high voltage installations. And in order to do that, basically Neutrik had to design them in a way that would make it difficult to impossible to solder them effectively. And one of these days I want to try to do it and just see if I can figure it out. But they've purposely made it really hard. So to do this connector, you're not going to use your soldering iron. We're going to do it the other way, which I am about to show you. So here is here's the cable. You can see inside of it, there's 4 wires in here, hence the NL4, right? There's 4 wires. Notice this wire is quite a lot thicker than what you've been working with so far. There are a few different parts to this thing. There's a boot and a strain relief. Both need to go on before you do anything. Okay? So we're going to slide this on here, if I can. There we go. So put that on, and then you're going to put this on. and it goes on this way. Okay, not this way. Very, very important. Okay, but you got to put both of these things on first, and you put the part that flares out points away from the end of the cable. Okay, so you put both those on. Once they're on, you're good. If you forget that even one of those things, you got to start over. Okay. Good news is you're not soldering this, so starting over is not quite as a dramatic problem. But there you go. Okay. So what you're going to do is you're first going to strip off the outer jacket here, and again, you're looking for about 1 inch. You don't want to do a whole lot more than that, or that strain relief won't grip the right spot. So be super careful not to cut too much off. And there's not a whole heck of a lot of insulation here between this outer jacket and the wires inside. They have their own insulation, but you know, you don't want to cut into them. So be super careful with that. You see, I nicked that one just a little bit. We'll see how bad it is when I get it all off, and I'll decide if I want to do that again. I also cut this crooked, which is annoying. All right. All right, let's see. How did I do there? Did I get all the way through? No, I think I'm all right. I don't see copper, so I think I'm okay. All right, so you've got a white, a black, a red, and a green. And if you look at the connector, you can see they're labeled. So you've got one plus, one minus, 2 plus, 2 minus. That's what they're labeled, okay? All right, so here we go. You're going to strip about 1/3 of, so this inch here, you're going to strip about 1/3, not quite half. You want to have enough that it'll slide all the way in, but not so much that any will be sticking out when it goes inside the connector. And this is 12 gauge wire, so those of you that are using the strippers that have holes in them are going to want to find the 12 gauge hole. Okay, and I'm going to just strip and twist each one of these. You want to make sure, you know, just like double check and make sure you're doing each one, stripping each one about the same. Because if they get vastly different from one another, that presents some new kinds of problems for you. So try to get them close. And these automatic strippers like I have, they don't work quite as well on this thick of wire, as you can see. Okay, yep, that's going to work. And one more. By the way, I put on Canvas the PDF that has the official instructions on how to do this from Neutrik. They made a little PDF that has all this information if you want to look at that, if that makes more sense to you. Okay, there we go. So here's what we're going to do. You've got white is going to go to 1 plus, black goes to 1 minus, red goes to 2 plus, and green goes to 2 minus. Why? Because that's what I said. White goes to 1 plus. Black goes to 1 minus. Red goes to 2 plus. And green goes to 2 minus. Now, if you actually terminate actual high voltage electrical cables, it's the white and the black is backwards. In sound, we usually use white as hot, but in electrical land, they use white as neutral. So just try to keep your wits about you if you end up doing any lighting or electrical work. Like the color coding is different, but generally speaking, for sound, white is hot, meaning you're positive, and black is your negative. And then if you've got red, green, red is usually your hot, and green is your negative. Okay. It's not written down anywhere. No one decided that. You know, officially, that's just kind of how we do it. And if we all do it the same way, then it makes some sense, right? There's a lot of things like that in sound that we've just all agreed as sound people that we're going to do it this way, not because anybody told us, just because we have to agree or things get complicated. Okay, so if you want to be a sound person, you just have to go along with it. It's one of those things. So I'm going to arrange these in the way that they're going to be. So you see how I've twisted them in this order because this is the order that they lay out on the connector. So I've got white on top and red going clockwise, white, red, black, green. And then I'm going to find the 1 plus and put that on top. And I'm going to slide this in there and push it all the way in. Now, here's where it gets exciting. Neutrik has a very specific tightness that they want you to tighten this screw so that it will stay put and not come out, but not squish the cable so much that the cable wants to escape. Okay? Too loose, the cable will fall out. Too tight, the cable will try to escape. And so this is what's called a torque screwdriver, which means I've got it set to a very specific torque and that is specified by the manufacturer. And this is a T8, Torx 8 screw. And I'm going to tighten this until the screwdriver slips. It'll kind of slip under your hands and it'll click like that. And that's when you know you got the right torque. You don't need to do it every time with a torque screwdriver, but I just have one here so you can do it at least once with that, once or twice, to get a feel for how tight that is. And once you kind of get that in your bones, then you can do it with your own screwdriver, because I had you all buy a screwdriver that had a T8 bit in it for this purpose, okay? So you don't have to come in here and get my screwdriver every time. You can use your own, just like do it a couple times with my screwdriver so that you get a sense for how tight we're talking. If you're off a little in either direction, it's fine. I don't know how precise the screwdriver even is. Yes? Yeah. It's in that PDF I gave you, but it is like 6.5 inch-pounds, which is not a whole lot. All right, so now I will put the black one in to, let's see. Oh, I got these, I didn't arrange these quite right, it looks like. So I want to have, the black one is going to go over here. Then the red one, I got the red and the black one backwards. Okay, here we go. So the black one's going to go into 1 minus. And you want to try to slide these in without fraying the wire, okay? You don't want any extra wires sticking out, okay? That's bad. So don't do that. So here we go. Let me try to, they're fraying on me a little bit. Twist them a little tighter. I'm going to cut this a little bit. I think I stripped it a little long. Because I'm pushing it all the way in, and I still got wire that's sticking out. So I'm going to trim this one just a bit. And try again. Okay, now let me get my screwdriver here. And you want to be pushing the wire in while you're screwing this down so it doesn't slide out. My bench is moving on me. That's annoying. So annoying. Okay. One more try. Get in there, you. Oh, that's better. That's way better. Okay. Okay, you hear that click? You'll feel that click too. Okay, so now I'll do the 2+, which is the red. We'll slide that in. Now what you'll notice is in the connector, they've got these little walls here between each terminal, which help prevent those wires from shorting to each other. So even if you see it sticking out a little tiny bit, it's not the end of the world. It will insulate you from that, but try to prevent that as much as possible. Get it stripped just right. This one I think is a little long too. Like I say, one of these days I'm going to try to solder these. I think that would actually be easier than this. Stick it to the man. I'm really having trouble with this one. All right, I'm going to skip over to the green one for a sec because that red one's not cooperating. We'll do the green one. Part of the issue is this is about the thickest wire you can put in this thing. So I'm right at the edge of what it wants to take. Oh, that went in like butter. Why can't they all be like that? That was glorious. Okay, here I go, last one. You can do it. Get in there. Okay, let me take a look at this and see how I feel about it now. I really am not super happy about that black one. There's a bit more copper showing there than I really like. I'm going to do it one more time. Try again. see if I can get a little bit better. Trim it a little bit better. I see part of the problem is I stripped it a little wonky. Okay. All right, I think I feel better about that. Okay. Now, here's where it gets interesting. It's not interesting enough. You're going to take this and slide this on. And there's little notches in this connector to line it up with certain little grooves, so you want to get those right. The thick one is that way. There we go. Okay. Now, before I slide it all the way on, let me get this thing. And there are these little notches in this white thing that slide right there, you see? There's a wide one and a narrow one. You want to get them in the right spot so that this thing will slot right in there, okay? Now, you can just bring this in. Now look what happens. See, as I slide that down, this starts to grip. Very, very important. Now I can get the rest of the boot. And I'm going to start turning this. Try to get it to catch. There it goes. Okay, now, more special tools. These are special tools that Neutrik made for the purposes of tightening these cables together. So this one goes here. This one goes here around the back of the boot. And it's a tight fit, so you want to make sure you really get it in there. Come on, little guy. You can do it. Okay, I think I got it. And now Neutrik has also specified a very specific torque for tightening this, which requires a different tool, an actual torque wrench. Now, to make this work, you want to hold it all the way back here at the handle, and you turn it till it clicks. And when it clicks, you're done. And if you do it like that, and the thing catches on fire and the building burns down anyway, I don't know what happens, but it won't be your fault. Okay? They won't say, why'd you solder that thing? Or why'd you do it wrong? You didn't do it according to the manufacturer's specifications. Well, now I have. I've done it according to the manufacturer's specifications, and that's okay, supposedly. All right? Any questions? All right, when you're ready to move on to that, you will find bags of NL4 connectors and little spools of 4-conductor cable, and you may begin on that. If you're not ready for that, that's cool. Keep working on whatever you're working on.